and other one is the refractive indices and Nichols prism. Okay, so by using these different applications, you can easily understand the concept of the polarization. Okay, so we can go for the introduction part of the polarization light. So here you have to know about that the phenomena of the polarization, which is going to be exhibited by the light waves. Okay, so which was established the fact that they are in transverse in nature. So here two things you can able to understand, that one is the longitudinal wave, other one is the transverse wave. And the particle vibrations which is perpendicular to the propagation of the light, then that is related to the transverse wave. In the case of transverse wave, you can able to observe the crust and troughs. But whereas in the case of a longitudinal wave, the propagation of the wave as well as the vibration of the particles both are parallel to each other, that is related to the longitudinal wave. In the longitudinal wave, there should be a compression as well as the rarefractions you may be observed. So the thing is that here, if you want to understand the phenomena of the polarization by the light here, that is totally related to the transverse waves. So here, there are three types of polarized light we can be produced from the unpolarized light. That means here unpolarized light means the light which is going to be scattered in all the direction, 360 degrees. Okay. So, but whereas if you are going to be here, that unpolarized light, if you want to convert into a plane, a single plane, so or else in only one single direction, then that light becomes a polarized light. By using such phenomena, by using such polarites, you can able to get the polarized light. So these are the line rarely polarized as well as the circularly polarized light, elliptically polarized light. So the essay question which may comes here, Huygens theory about the polarized light is that here circularly polarized light as well as the elliptically polarized light. So from this concept, you may get an essay question. And next one is the polarized light, which can be very extensive applications to understand the nature of the substances here. So many applications are there related to this concept here. Whenever a ray of light which is going to be incidenting upon a glass plate which is a smooth surface. So what do you observe here? First of all, when the light is going to be incidenting upon the smooth surface means automatically the light which is going to be reflecting. That means if it is going to be incident at a normal, by making an incident angle at the same direction on the same media, the light which is going to be makes an angle and which may moves in the other direction, that is going to be caused as here reflection. So, and other thing is that one from one media to the another media at the normal, the light which is going to be bending and moving away from the normal, or else if it is moving toward the normal, that is here refraction. Okay. One media to the another media, that is the refraction. Same media, if it is moving away at the normal, that is reflection. So these are the basic concepts about this reflected and as well as the refracted layer. So here the reflected and the refracted rays obey certain laws here. So here the thing is that in certain crystals like calcite crystals, which you may be observed the case for two refracted rays for a single incident ray, and this phenomena you can observe in the case of a double refraction. Okay, so this is the case for the double refraction. You can easily observe that. I will show you the case. Uh, where is the figure? Yeah. So a narrow beam of light which is incidenting normally on any face of the calcite crystal. So two spots, O and E. O means ordinary ray, E means extraordinary ray. Okay. So these two will be observed on a screen which is placed in the path of the emergent light. If the crystal is is rotating about an axis and parallel to the beam of the light here. Ordinary remains same. That means ordinary ray, the position is not going to be changes. Only extraordinary ray, which is going to be rotates about the axis. Okay. So that is the case here. So that a single incident beam, which may gives you two refracted beams. One is the ordinary, which is correspond to the single beam, and which have been transmitted a substance like a glass being used, and this beam which obeys the ordinary laws of reflection, which is called ordinary beam. And the other thing is that extraordinary ray. So you know pretty well about the Snell's law. Snell's law is nothing but a mu equals to the ratio of the sine of the incident angle to the refracted ray. So that is a sine A by sine R. That is nothing but a Snell's law. And for extraordinary ray, sin A by sin R value, which depends on the angle of the incidence. And what do you mean for this condition means here? Sin A means velocity of light in air, and sin R means velocity of light in the medium. That means medium which may be a denser medium. That means a glass material. So which is nothing but here. Sin A by sin R is nothing but a mu. Mu means a refractive index. Okay. So the ratio for the ordinary beam, which is indicating the velocity of the light in the medium, same as in the all directions, and the lack of the constancy of this ratio, extraordinary beam, which is indicating that velocity of the component of extraordinary, which is different in different directions in the crystals. So in actually in calcite crystal, double refraction, which may be observed in all directions. So the particular direction, which is called a optic axis, and it may be concluded that velocity of two beams which are in equal in this direction. Along the optical axis, extraordinary as well as the ordinary rays velocity should be same. That axis is optic axis. Whereas in double refraction, which may be observed in the crystalline substances like calcite crystal, quartz crystal, ice, tourmaline, apatite, nitrate of soda, thorax, mica, celandine, topaz, and agonite. So these crystal may be divided into two groups. One is the uniaxial, other one is the biaxial. Okay. So in biaxial crystals, there are two directions. That means along with the ordinary and extraordinary beam, travel with the same velocity in biaxial. Whereas in uniaxial, there is a difference. That means only one direction. That means the crystal mentioned above, the first six are uniaxial and the rest are biaxial. So you need to check out that here. This may be asked as a short question, very, very important, about the calcite crystal. If the question comes, you can give it. So here, what do you mean by polarization? So in interference, you know pretty well. Diffraction phenomena, which may be explained by using the assumption of the light and how the energy travels from place in the form of waves. And we could be different types. One is the longitudinal, another one is the transverse, and the other is the surface. So here the question is that what type of phenomena, wave phenomena, which is going to be involving in this of light. So all the types of wave mentioned about to produce interference as well as the diffraction. But for polarization, which may gives a clue to the exact nature of the light waves. So according to the electromagnetic waves, EM waves, there should be the electromagnetic wave means here the radiation. That means here which is in transverse nature. And electromagnetic means electric component as well as the magnetic component. Electric component means capital E and magnetic component means capital B. where E and B both are perpendicular to each other. This is the most important objective bit. So electric component capital E and magnetic component capital B both are perpendicular to each other. Okay. But the propagation of the wave which is in other direction, that is also perpendicular to these two components. Okay. So remember this. I will show you the diagram also. The electric and magnetic vectors in a light wave vibrate in mutually perpendicular direction. And in addition, the two vectors which are perpendicular in the direction of the wave motion, the electric vector execute our visions, and which may be considered only the electric vector for the purpose of the discussion. And the end of the ordinary light ray, which may be the plane of vibration of the electric vector, which are perpendicular to the direction of the propagation. If it is possible to resolve these vibrations along these two mutually perpendicular, that this. So this is the electromagnetic wave. So I will show you one thing. Electromagnetic. Is it clear? So here, what causes the phenomena in this picture? You can see that here. This is a blue sky on the surface of the earth. If you are going to be observing, the cloud should be like this. But whenever you are using a Polaroid, this is the instrument, a Polaroid, you can easily observe that how the clouds will be appeared. Okay, a clear picture is going to be observed while you are using a Polaroid. So the polarization is like this. Polarization. So what kind of waves can be polarized? So all the transverse waves which comes under the concept of the polarization. So where do you observe the transverse wave? The waves which may produce in a string. Okay, one end is fixed, the other end if you are going to be transferring the energy. So that how the energy which may flow or transfer through the string means transverse nature. Okay. So that is the case. Other one is the all the light waves which are in transverse nature. Light waves. Okay. So here a plane polarized. If you consider that X, Y, Z. So XY is a one plane, YZ is another plane, and XZ is another plane. So that whatever it may be here, the wave is always in a single fixed plane. Always in a single fixed plane. That is called plane polarized light. So you can see that the string wave is vertically polarized here. This is the string, how the energy which is going to be transferring. Okay. And here it can passes through a vertical filters. See here in this, where here. Vertical filters only the wave, which wave? Transverse wave is passing through this. But whereas this is the horizontal, getting my point? Okay. Here the wave is not transferring. Here the wave is transferring. Okay. So this you may cause, which is a plane polarized light. Is it clear? Next, light waves are transverse nature. So here the light which may consist of perpendicular oscillating electric as well as the magnetic. Just now I already told. So we are going to be concentrating on the electric fields in this discussion. So because of our eye, which is very perceived, so you can see here in this. So what do you observe? Where is electric field and where is the magnetic field? How the wave, in which direction the wave is going to be propagating. Okay. So this is the AC signal. So AC means alternating. So that here along the you can see here uh, X, Y, and Z. This is the Z direction. Okay. This is the Y, and this is the X direction. Getting my point? Okay. So, or else whatever it may be, if you consider that this may be X uh, from the figure only. We are going to be talking about that here. If the component which is Y, it may be Z, it may be X. Okay. So, this is an AC alternating. So, ACC. So, here you can able to see that here the component of the uh, electric field, the component of the electric field, which is vibrating along the y direction, whereas the component of the magnetic field, which is vibrating along the x direction. Could you able to see that here? So red color, which is indicating here component of the electric field, which is vibrating along the y direction, and the component of the magnetic field, which is vibrating along the x direction. The thing is that here between x and y, both are perpendicular, 90 degrees. That means you need to say that here the electric field as well as the magnetic field, both are perpendicular to each other. Okay. The thing is that the propagation, okay, these are vibrating in different directions, but the propagation along the z direction. Okay. Whatever it may be in place of x, y, z, whatever it may be, if you are going to be like this, okay, either x or y or z or depending upon your choosing point. So here the particles are the component of the uh, electric field as well as the magnetic field, both are perpendicular and those are to be vibrating uh, in different directions. But the particle's energy, which may be transferring from the one particle to the another particle, that is along the other direction. This direction is also perpendicular to these two components. Getting my point? So this type of wave you can call it as what type of wave it is? EM wave, electromagnetic wave. Is it clear? So that is very, very important. So this indicates the electromagnetic wave. Is it clear? Next. See here how the wave propagation is going to be takes place. Next is the polarization light by absorption. So an unpolarized light has an electric fields in all directions. But when the passing the unpolarized light through a filter, which may be reduces the intensity of the light by 50%. Okay, you can see here. So this is the case for the uh, unpolarized light. Here, this is the unpolarized light. Okay. So this unpolarized light means which is scattered in all directions. So which is scattered in all directions, the unpolarized light. So here, which is passing through a polarizing material, this one. This is a polaroid. When it is passing through a polarizing material, what will happen here? The intensity of the unpolarized light, which may be reducing to 50%. Okay. Only vertical components are present. No horizontal components, other components which are not passing through this polaroid. So that you can easily observe the unpolarized light. Getting my point? This diagram is very, very important. You can go through this. Next, polarization by the transmission. I'm giving the only keynotes. Later on, we will go through this. Polarization by the transmission. What happened when polarized light passes through additional filters? Okay. So an unpolarized light which is passing through a polarized, the intensity of the unpolarized light which is going to be reduces, then you can easily observe the case. So if whenever solar eclipse is going to be takes place, how the scientists and other normal people are going to be observing the condition there? If they are going to be directly observed, no one can see the directly. Why? Because of UV rays, which are very high intensity and high radiation. Uh, in the case of solar eclipse, those rays are going to be enter into the Earth atmosphere. So if you are going to be directly see that phenomena, our eye retina will be damaged. And also those rays, if it is going to be hitting and incidenting upon your skin, there should be a skin cancer is going to be takes place. And more intense of light is going to be produced. So that whenever a polarides are going to be used to observe the phenomena, you can easily see that. That means the intensity of the light which is going to be reduced by these polarides. Getting my point? So the question is that uh, when a polarized light passing through a additional filters, what will happen? The thing is that according to the Malus law, here I equals to I naught cos square theta. So I is the intensity of the transmitted light. I naught is the intensity of the incident light. Theta is the angle between the electric field and filter's transmission axis. Okay. So like that you can easily observe. So you can go through this Malus law. So this is the apparatus and a polarizer. This is the unpolarized light, a polarized, and from this you are going to be observing The intensity, you can see here, this is very, very bright here. This is less bright. Okay. The brightness is reduced. The brightness means here intensity of the light. Unpolarized light which is reduced. Is it clear? 50 pets. Next is the polarizer and analyzers. So polarizer means a polarizing filter which may use it to produce the polarized light. Whereas analyzer, it is going to be analyze. Analyze means detecting. A polarizing filter used to determine if light is polarized. So unpolarized light intensity which is reduced by 50% while you are using a polarites when it is passing through a polarizer or analyzer which is regardless of the orientation of the polarizer or analyzer. Already polarized light's intensity is going to be reduced depending upon the orientation of the polarizer or analyzer according to the Malas law. Next, polarization by reflection. When unpolarized light reflects off a non-metallic surface, the reflected ray is partially polarized. An unpolarized light reflects off a non-metallic surface. The reflected ray is partially polarized. A plane of polarization is parallel to the reflecting surface. Plane of polarization is parallel to the reflecting surface. Next is the Brevester's angle. At a particular incident angle of the reflected ray, 100% of polarized along the plane parallel to the surface. So you can see here, uh, this is the unpolarized light. Okay. If it is going to be incidenting at the normal, which makes an incident angle, and at the same media, reflection is going to be takes place. Here, refraction is going to be takes place. Okay. So the angle between the polarized light and slightly polarized refracted ray is 90 degrees. Okay. So refracted ray which makes an angle is theta 2 and unpolarized light which makes an angle with the normal is theta. Okay. So this may occurs when the angle between the reflected and refracted ray is 90 degrees. So the case is that a particular incident angle, the reflected ray is 100% polarized. Okay, now when the angle between reflected and refracted ray is 90 degrees, then only you have to say that the light is completely polarized. By applying this Snell's law, sin I by sin r equals to mu. That is n1 sin theta p equals to n2 sin theta p. Theta r is nothing but a here 90 minus theta. Sin 90 minus theta is cos theta p. So sin theta p by cos theta p is nothing but a tan theta p, that is equals to n2 by n1. R as tan theta equals to n. So we can go for the Brevester's angle. I will show you one diagram, one video through a YouTube. So you can easily observe the concept which is related to the Brewster angle. Please wait, I will play a video. Uh, a small video.
All right, I have here a large refraction tank with water. There's a tiny bit of scatter liquid in it so that when the refracted beam goes through the water, you can see its path. I have a light source here, a white light source. I can change its angle of incidence with the water by moving this arm. The arm is counterbalanced, so I can move it to a position and release it with my arm to stay there. I'm going to now turn on the light source, and I'm going to shut off the room lights. And one more thing I want to say before I shut off the room lights. For this demonstration, I'm going to take a polarizing film and I'm going to rotate it in the path of the reflected beam. So let me shut off the room lights now. Here we are in the dark. And there's the reflected beam coming down off the water and then striking this diffusion screen up there. And that's away from the Brewster angle. So I'm going to take this polarizer and rotate it. And when I rotate it, I cannot extinguish that spotted light up there because it's not completely polarized. But if I change the angle of incidence with the water, so now it's at the Brewster angle for water, now it's maximally polarized. So now I can insert the polarizer and rotate it, and I can extinguish that spot and rotate it back parallel. So I have to be at this Brewster angle to have maximum polarization.
So this is the one of the best example for the how the Brewster angle is going to be takes place towards the normal when if it is going to be passing through in a water, how the polarization is going to be takes place, how the Brewster angle is to be measured. That was explained successfully by Dinas. And here, again, we will go back to our concept. Next one is the optical activity. So, which is the rotation of the plane of the polarization. Which is the rotation of the plane of the polarization. So, materials which are going to be showing this phenomena, which is called optically active. So, essay question, 100% an essay question. Laurent half-shade polarimeter. Okay. So, an experiment is also there in our physics lab. You have to find out the specific rotation by using the Laurent half-shade polarimeter. So, this activity, optically active, that is optical activity, which is observed in sugar solutions, tartaric acid, turpentine, quartz crystals, in also liquid crystals, and also in liquid crystals. You can easily observe this phenomenon. So where we are using this? We use it in measuring the solution concentrations. Probably we are considering in our laboratory sugar solution. Okay. So solution concentrations. And LCD, not LED, not a LED light emitting diode. LCD in liquid crystal displays. Before LED, LCDs are used. Got it? There only we have been used this optically active phenomenon. Remember this. LCDs, liquid crystal displays. So you can see LCD concept. So, so one is the first one is the polarizing filter. This is the polarizing filter. Here there is a glass with shaped electrodes are there. And third one is the twisted liquid crystal. This one. Fourth, glass with common electrode film. Fifth one is the polarizing filter. Sixth is the reflective circuits. Okay. So LCD which may contains all these six. So polarimeter, Laurent offset polarimeter. So what is the main use of this polarimeter is means which may use it to determine the concentration of the optically active substances. Usually sugar solution concentration. Optically active substances. So this is the uh, polarimeter. So how polarimeter which may works here. This is the light source. Light is an ordinary here where this is the light source which is an ordinary light which is uh, scattered in all directions. Whenever you are using a polarizer, this is the polarizer you are using so that the intensity of the unpolarized light which is maybe reduced, okay, to a plane. So that is a polarizer. So if it is going to be passing through a sample tube, in the sample tube only, we are taking a sugar solution with different concentrations. With different concentrations, we have been considered and choosing the solution in this. So this is a vertical. This is in vertical. When the light is unpolarized light, which is passing through a polarizer, you are getting a vertical light. Again, if it is passing through a sample tube, which may have a sugar solution, and the orientation of the vertical polarized light, which becomes a horizontal. Did you see that? If it is emerging out like a horizontal. So other polaroid which may be used as an analyzer. Getting my point? So same polarizer here and there is a analyzer. So that again the horizontal which may becomes a vertical, but the intensity which is very less, and you can easily observe the observer. Okay. So the amount of the rotation which may depends upon the length of the sample tube and also sugar solution concentration. That's what here in our experiment we are going to changing the sugar solution concentration. Okay, na? Next is the some compounds rotate the polarized light to the right. That is dextrorotary and other to the left levorotary. Okay, levorotary. That is the case. And other homemade polarizers. You can go for the YouTube. You may observe homemade polarizers and stress analysis using polarizers. This is the so these are the best examples. Quickly, we can go for it. Here, concept of polarization, types of polarization, methods of achieving polarization, applications of polarization. So, ordinary light means here electromagnetic wave. There are two components, electric field component capital E, magnetic field component E. Both are perpendicular to each other. And if those are in phase and also which are also perpendicular to the direction of the propagation of the light, then these waves which are nothing but a electromagnetic waves. So this is the electric field vector. Okay. Along the y direction and the z direction is other component, the direction of the propagation which is along the x direction. Red indicates electric, blue indicates magnetic. So how the orientation which maybe takes place. Next, ordinary light. The unpolarized light, which may contains a large number of atoms, which may producing the waves with particular orientation of the electric field vectors, and the resultant wave, which is unpolarized wave, and the superposition of the waves vibrating in all possible directions. Polarization means here transforming unpolarized light into a polarized light, and the restriction of electric field vectors capital E in a particular plane so that the vibration which may occurs in a single plane. So the characteristics of the transverse waves and longitudinal waves cannot be polarized. Why? Because of here the direction of the their oscillation which is along the direction of the propagation. Both are parallel to each other. That's why here you may not be observed. Okay. So you can observe that an unpolarized light, a beam, incident beam, these are the filters. A polarized vertically, another polarized is a horizontal. So only vertical components which are passing through this filter, horizontal may not comes to this. The plane of vibration. So a plane includes the direction of the light propagation and the direction of the electron. Plane of polarization means perpendicular to the plane of vibration. So you can see the tourmaline crystal. Before that, calcite crystal, double refraction. So by considering a tourmaline crystal here, ordinary light which is passing through this, and the vertical unpolarized light which may be coming out and emerging out from the tourmaline crystal. So the plane of vibration along this and plane of polarized light is this along the BC direction, and whereas the EG direction there is a plane of polarization. So why only electric field vector is considered in polarizing and not magnetic field? So according to the Maxwell's equations, E equals to CB, where C is the velocity of light or speed of light, that is 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second, which is very large value. So that E is far greater than the capital B, that is EM wave, electromagnetic wave, is predominantly an electric wave. So to change any characteristics of electromagnetic wave, including polarization, capital E should be effective. Next, types of polarization: linear polarization, plane paths, linear polarization, circular polarization, elliptical polarization. So linear means this, circular, a plane polarization, elliptical polarization. So linear polarization, a plane polarized wave is to be considered. Electric field vectors which are oscillating along a straight line in one plane is nothing but a plane polarized line. That is related to the linear polarization. You can see this is unpolarized light which is passing through a polarized only. Here vertical components which are to be reached. So resultant wave which is in vertical and resultant wave is linear in 45 degrees. Superposition of plane polarized. When two plane polarized waves are added according to the rule of vector addition. That is, superposition means the sum of the displacement of the total displacement of the two or more waves is equals to the sum of the displacements of the individual waves, which comes under the superposition. So two plane polarized waves are adding, and according to the rule of vectors addition, then it can gives the result of the linear, elliptical, or circular polarized waves, which is depending on the amplitude and also phase shift between these two. Next, circular uh, circular polarization, which consists of two perpendicular plane EM waves with equal amplitude and 90 degrees phase difference between them, and a plane of oscillation which is rotating around the propagation axis, and which may be right circularly polarized, that is clockwise, or left over is circularly polarized is anti-clockwise. This is the blue color, which is a circularly polarized. Superposition, which may gives the resultant to plane polarization. Next is the elliptically polarization, which may consist two perpendicular waves of unequal amplitude, which may differ by the 90 degrees angle. So the tip of the resultant electric field vector, which may be describes an ellipse in any fixed plane and intersecting and normal to the direction of the propagation. Circular and linear polarization, special cases of elliptical polarization. Blue one is the elliptical, where gray is the here resultant elliptical polarization. Methods of achieving polarization. An unpolarized light can undergo polarization by reflection of by non-metallic surface like snow, glass, like that. So if the incident angle such that angle between reflected and refracted ray is 90 degrees, such incident angle is okay, by a polarizing angle or a Brewster. Reflected ray which is linearly polarized parallel to the reflected. This is the case. Brewster angle. You see that? We have been already discussing this concept. So figure A is no polarized are used here. Here is a vertical polarized. This is a horizontal polarized. Where do you observe the clear image, clear picture? That should be in the case of horizontal polarized. And polarization by scattering. Light is scattered, polarization also occurs. So if it is going to be striking the atoms of materials, electrons which are set into vibrations. So vibrating electrons which may produce the EM waves, and these are generated waves strikes neighboring atoms. So absorption plus re-emission is nothing but a scattered light. So scattering which may be occurred in the atmosphere leading to blue sky. So double refraction, birefringence. We will discuss in the tomorrow's class. Okay. Right. All the best.